Hi everyone. I welcome you all to my YouTube channel. And today we are going to continue our discussion on Singleton Design Pattern. Uh, and our topic for today's session is lazy and non-lazy loading in Singleton Design. In the last session, we have already discussed about lazy loading in Singleton Design Pattern. We have already seen how the lazy loading works there. We have already seen the lazy keyword, and we have already seen that it's thread set. So we have already seen like what is lazy loading and right. So and in the last session, and if you have not seen my last video, you can go ahead and see my last video where we have discussed about it. Now let's talk about the non-lazy or the eager loading today, and then we will see when to use lazy loading, when to use eager loading, and which is better, right? So, and let's talk about the lazy loading one more time. So, lazy loading, as we have seen earlier, right? That we can call a lazy loading. Lazy loading is nothing but it's a kind of concept, or it's a pattern where we can hold the initialization of the object till the time we need, right? We can defer the initialization, or in other words, we can say it's a kind of on-demand initialization. So, so we can initialize the object when we want, right? It's not that it can get initialized anytime. So it is up to us when we want to initialize. And unless we want this object to be initialized, it will be, it will not get initialized. So this is all that is. If we are able to implement that, we can call it a lazy, right? So now let's talk about our non-lazy or eager loading design pattern or singleton design. I mean, implementing non-lazy or the eager loading in singleton design pattern. So let's open Visual Studio. This is our same code, what we have already seen earlier, singleton static read only, where we have a field or attribute, which is returning me an object of the singleton static read only class. And here what it is going to do is it is going to create a new object, right? Apart from that, I have created one method, and I'm going to call this method just to see how my eager loading is working or not working. And I have a static constructor, and then what I have is I have a private constructor. We all know what is the use of this private constructor, and we'll see the use of this static constructor in a while when we run the program. Now let's talk about this get instance. This get instance is our public method, which is going to return us an object, right? And as we have discussed earlier also, either we can use get instance method, or we can use a public property to get an object of our singleton class, right? So, and this is our main code, main method, where I'm calling this test method multiple times just to see how my eager loading works, and we'll just see it in a while. And then we have the same code what we have used in my all the old our previous sessions, where I'm calling all three methods parallelly: create first object, create second object, and create third object method. And this is our create first object, create second object, and create third object method. Whereas my create first object is also creating an object, and I'm printing a message saying that as one object got created. And creates a second object is also creating object, and it's giving me a message saying that as two object got created. And create third object is also going to create an object, and it will give me a message that the object got created, right? So now let's run this program and see how it works. I'm pressing F5 now, right? And let's do one thing. Let's make the size smaller and see how the execution works here. Just to put it here, right? And now I'm pressing F10, and let's see how the program flows. So what happens is it came here first, and then it goes to here, and then if you see singleton private, our private constructor is got called, and then our static constructor is got called, and then it comes to the test method, and says test method is called. So for the first time, now again it will go to second, and now it is not doing any kind of initialization. Now it just says test method is called. Now it is going for the third time. Now again it's directly calling this method. It is not doing any initialization now. It's called the third time also, right? And we have already got the object also created, if you see here, right? Now I'm calling first object, second object, and third object. Means create first object, create second object, and create third object methods. And what it's going to do is I'm just going to do a fast forward. because we have already seen this. So so now I have got all three S3, S2, and S1 object created, means all three are done. Now I'll be coming here. It will create again first one S1 object, and then S2 object, and then right. So right. So so now the program execution is completed. So see what all happened is, first of all, it called the private constructor. Why it called private constructor? Because here I am calling this new object, so it has to go here, right? So and then so actually I had called this test method, right? But even before it called this test method, it started doing the initialization of all these steps, right? So this is how, and then that is why I call it as a eager loading. What happened is, even before I actually call these create methods, right? This create first object or create second object or create third object, which is actually calling this get instance, right? Or which in turn should have called this new thing and all, right? New Singleton static read only and all, right? So instead of doing that, instead of waiting for that, when I'm calling this test method, at that time itself, what it did is it created an object called, right? It did not wait for these methods to be called, which is actually responsible for creating the object, right? So this is what is called as a eager load, right? So even before I am trying to create an object, right? But for the first time, whenever I am giving a reference of my class, this class Singleton static read only, it actually initializes all the static members, and by doing this implementation, we were able to create the object. Now let's do one thing. I'm just commenting this code, which is my static constructor, right? And I'm running it again. Let's close this. Now I need to. Fine. We'll see a different kind of behavior. Let's see. Right? It's the same method. I'm calling this test method. And now if you see, it directly went to test method. It did not do any kind of initialization. I'm calling it second time. Right? If you see, test method is called. Second time also is done. Right? Third time is also done. Right? And now it's a normal thing that we have already seen private constructor we call it. Right? So it means if we have a static constructor, right, in our Singleton class, right, and then we have this kind of implementation, we can implement eager loading in Singleton Design Pattern. It means we don't need to wait till the time our object we need the object to be created, but still our object will be readily available as and when we need it. So actually, when we are calling this, we already have an object, so it doesn't go and create an object next time, right? It already has an object. It just say return instance, and I get an object, right? So this is an example of the eager loading and the importance of this static constructor as well, right? The static constructor will be called only once, and the static constructor is not only for static class; it can be there in any class, right? So hope you have understood this eager loading. Let's go to our slide and talk about the other things, right? So what happens in the case of eager loading? So in this our case, what happened is, though one advantage is my object will be readily available, right? But the other disadvantage of this pattern is, if my object creation takes a little bit more time, then our application, right, will take even it will do some other extra, right? Whenever even if I don't need an object, it will create an object and it will keep it in memory. So it depends, right? So now the thing is, now let's say if the time is very early, but if you see in our example, right, where the time what it took to create an object is almost negligible, it doesn't give a lot of performance benefit. But in such cases where, let's say, the object creation takes 2 seconds, 3 seconds, or 4 seconds due to some dependencies, it has to get connected to some other tool or some other external component and all, and then it has to create an object. Let's say it has to create some connection. Let's say I'm using RabbitMQ or something, and then I wanted to create a connection out of it, and then I have to keep that connection for all time. It may take some time because RabbitMQ is some other place, some other server. There could be some network delay and all those things. And if you really wanted to avoid that, but point that we need to keep in mind is, Singleton design, in Singleton design pattern, we don't need to create object all the time. Once the object is instantiated, it is done. From next time, we're not going to create an object. So it's just a one-time initialization, and after that, no initialization is required. So no, it's a very less difference that I can tell until unless you see like big difference. I don't see a much difference between a lazy loading and eager loading in case of Singleton design pattern, because we don't need to create object all the time. There is no locking. We are not in .NET framework by using this static method and the read-only keyword, right? We are able to remove blocking and all those concepts as well, right? So now it depends. So let's say when we wanted to talk about when to use eager or non-lazy loading. So, or if somebody asks me like, no, what is better, eager loading or lazy loading? It's very difficult to tell, right? So I cannot say this is better or this is not better, right? It depends on our use case. So it's something like I do not want my system to wait for a longer time before my application gets loaded, or I do not want to initialize my object unless I need it, right? Then I can go for the lazy load, right? If that 1 second or if some millisecond also matters to me while application loading, or for some other functionality that, let's say in our case, we were trying to call some test method, but before it called the test method, started doing the initialization, and during the initialization, it created an object of my singleton class. And if I don't want that to happen, right, then I can use lazy keyword and I can go for the lazy, right? Whereas the object instantiation will be that control will be with us, right? But in such scenario, when we want our object to be created and readily available, even before I am trying to use it and all, it's going to be used heavily and all those things, that kind of use case that we have. And I don't mind waiting for a couple of milliseconds or some seconds, right? That it might take during the application loading and all. We can go for eager loading as well, right? Now, next question is, which is better? So after understanding that we know what is lazy loading and what is eager loading, and again, it is case to case basis and it is based on your use case. So I cannot go ahead and tell you this is better and that is better, and this is not better, right? So it is something that you up to you to decide, right? Based on the use case, what fits best for you and what is better for you. So there is no definition that this is better or that is better. Yeah. Hope you have understood about lazy loading and eager loading. And as I keep telling every in my all the videos, when you're going through these videos, just simply don't go through the videos. Please try to implement the same thing while you're going through the video, so that you can understand it in a better way, and it will be there with you. It will be there in your mind for a longer time. Also, if you see this video is helpful to you, and you are able to understand Singleton design pattern and all the concepts and all the topics that we are discussing here, right? And if you see if it is helping you and it's beneficial for you, please, it might be beneficial for your classmates or your colleagues. Please do share this video with all of them so that they can also get benefit out of it. Thanks a lot for watching this video, and we'll meet again in our next video. Thank you.